Since we've discussed the other two terms on the right-hand side of this equation, I think it's only fair to the point force vector that we spend a little bit time talking about it as well. In addition to body forces that can be distributed throughout the entire body, three-dimensional body that's represented by my modeled as a two-dimensional triangular element, and surface forces that can be applied along a surface of my two-dimensional element, of course, there can also be point forces, which I would design my elements so that all point forces applied would be applied at nodes. So if this is node 1, I could have a force F1. I could have a force F2, and I could have some force, maybe it's coming out this way, force F3. Of course, each of these forces can have a component in the x direction and a component in the y direction. So this could be F1x. This would be F1y. This vector P, much like it was in our one-dimensional bar and beam elements, can be written so that I have my force affecting node 1, the x component and the y component, F1x, F1y, and then the other various components, F2x, F2y, F3x, F3y. All right, that wraps up going over the three terms on the right-hand side of this equation. In our next video, we'll discuss forming global stiffness matrices and global stiffness equations.